Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to be talking about electrolysis and electrolytic cells. So let's get into this. So electrolysis is where you use an outside source, an outside energy source, in order to drive a non-spontaneous chemical reaction. So basically you might use a battery to then connect that battery up to your cell, and then that'll drive the non-spontaneous reaction. So let's get into this. So here, voltaic cells, that's where you're using a spontaneous reaction, a spontaneous redox reaction, and that's going to be used to produce an electrical current, and then that electrical current is used to either run a motor or turn on a light or whatever the case may be. For an electrolytic cell, you're actually going to be using an electrical current that's provided by an outside source like a battery, and that outside source is then going to drive the non-spontaneous redox reaction through the process of electrolysis. So electrolysis, for example, is where you are taking, say, water, for example, and you're breaking it down using an electrical current, breaking it down into hydrogen and gas. And we saw before, like with a fuel cell, which is a type of voltaic cell, you can use hydrogen gas and oxygen gas to then produce water, which is a spontaneous reaction. So in order to reverse that reaction, you need to then produce or provide a source of electricity like a battery that is going to drive that reaction in the opposite direction. Okay, so for example, one of the things I talked about a little bit at the end of the fuel cells video is basically where are we going to get the hydrogen? We need hydrogen to be available in order to run a fuel cell. And so one way you might be able to do this is to use solar-powered electrolysis to then drive the production of the hydrogen gas from water. So we got plenty of water out there. We could use that water to then use electrolysis that's during the day powered by the sun, and then that'll produce H2 gas, and then that H2 gas can be later used on to then run your fuel cell. Okay, so that's one possibility. Electrolysis can also be used to convert oxides, metal oxides, into pure metals. Now, in order to cause a metal to become pure, to go from an oxide to pure metal, that's going to require reduction, which is a non-spontaneous reaction. So what we need to do then is to then use electrolysis to drive that reaction forward. So we can then get sodium metal from molten NaCl, and I'll talk about that in another video coming up. Finally, you could also use electrolysis in plating metals. So you get your jewelry that has gold plating or silver plating or platinum plating or whatever plating of a certain metal. Your electrolysis will drive that as well. So for example, if you wanted to plate something with silver, you might have some source of silver as an electrode. So that electrode is then going to produce silver ions, right? So you can have an anode that is made out of silver, and then at the anode you have oxidation occurring so that the silver atoms are going to give off their electrons. That's then going to provide the silver ions. Those silver ions then can travel to the cathode, which is going to be your ring or whatever it is you want to plate. It could be a spoon, and excuse me. And then those silver ions then can be converted back to silver atoms at the cathode by being reduced. So they gain those electrons, and then they plate onto the object that you want to plate. So again, you're going to need the outside source to do that. So those are a few examples of how you can use electrolytic cells. The voltage required to cause electrolysis is going to depend on what half reactions you have going on. And so, as we saw before, the half reactions, when you add them together, is going to give you some overall cell potential. If you if you provide the voltage from a battery that's greater than what that cell potential is that's needed for the electrolysis, then the electrolysis will occur. And so you can get that to occur by hooking up enough voltage from an outside battery. Okay. And so let's end by comparing the voltaic cell to the electrolytic cell. In the voltaic cell, the anode is the source of electrons. So this is a spontaneous reaction. You hook up the two electrodes to each other by a wire. The electrons are going to flow automatically. So they're going to flow from the anode. The anode is the source of the electrons. That's where oxidation is going to occur automatically. The electrons are going to be given off by the source of the anode, and then they're going to travel through the wire, and therefore we give that a negative. That's a negative charge. So it's going to be more negative electrode potential here. And again, the cathode is going to be drawing the electrons. So in a voltaic cell, the cathode draws the electrons towards it because, again, it has lower potential energy. The electrons are flowing from the anode. It has a higher potential energy. It has a more negative electrode potential. Is going to flow towards the more positive electrode potential, the lower potential energy of the cathode. And so we have that as a positive. So remember, positive attracts electrons, negative pushes the electrons, repels the electrons. For an electrolytic cell, however, it's kind of switched. So the source of the electrons is going to be the external power source, whatever that is. That's where you get your electrons from. And so the external power source is going to be drawing the electrons from the anode. So it's going to cause the anode to give away its electrons. So you got to make that happen with a battery. So that means the anode is going to need to be connected to the positive terminal of the battery, right? So you got to have a positive terminal that's going to attract those electrons, draw those electrons from the anode. And so the power source then drives the electrons toward the cathode. And so therefore the cathode has to be connected to the negative terminal of the battery. And so therefore the cathode and the anode are going to have a charge label, plus or minus, that's going to be opposite that of what you see on the voltaic cell. So on the voltaic cell, the anode is negative and the cathode is positive. But for an electrolytic cell, it's the opposite. So the anode is going to be positive and the cathode is going to be negative. So that's it for this video. I hope you enjoyed this video. I'll be talking more about electrolytic cells and how you can predict products of different electrolytic cells under different conditions. I'll be talking about over voltage and all that stuff. So stay tuned for more videos. If you like this video and you learned from this video, please make sure you hit that like button right there. Like the video, share the video with others. Also, make sure you subscribe to my channel. Hit that notification bell right up there. Once you click on the notification bell, make sure you click on all so you can be notified for all the videos that I put out. Also, finally, put a comment down below in the comment section. Let me know what you think or if you have any questions. I'd love to hear from you. Thanks for joining me and have a great day.